In this video, we are going to discuss work done by gravitational force. Work is defined as a product of force times displacement. And we know for gravitational force, F is equal to m into g. So if an object was raised at a height h above the ground level, I can rewrite this work as mgh. This is the rule for calculating work by the gravitational force. Now, how do we know if this work is positive or negative? Let us consider two situations here. First, when the object is falling down, and the second, when the object is going up. So we start with the object falling down. When the object is falling down, when it is going down, the force due to gravity Fg and the displacement of the object h, they are both in the same direction. My F and D are both in the same direction. And we have discussed before that whenever force and displacement are in the same direction, work done in this situation is taken to be positive. So I can write my work done due to gravity when the object is falling down to be positive mgh. Because we can define work as F d cosine theta. And whenever F and D are in the same direction, the angle theta between them is 0. And when you substitute cosine 0, it will give you 1. So that gives you the work as F times D, which is positive F times D. So when an object is falling down, work done by force of gravity on that object is positive mgh. And since this work done is positive, gravitational force increases the kinetic energy of the object.
This is why when an object is falling down, its velocity increases.
Because gravitational force is doing work to increase the kinetic energy of the object. The second case is when the object is going up. When the object is going up, the displacement of the object is opposite to the force due to gravity. They are opposite to each other. F and D are opposite. And if F and D are opposite to each other, the angle theta between them will be 180. And when you substitute this in your rule for work, F equals Ft cosine theta, cosine 180 will give you negative 1, and that will give me my work as negative F into D. So if an object is going up, work done by gravity on that object will be negative mgh. So when an object is going up, the gravitational force reduces the kinetic energy of the object. This is why any object, when they are going up, their speed decreases. Because gravitational force is doing work to decrease the kinetic energy of the object. To summarize this, work done by gravity is equal to mgh. It is positive when the object is falling down, when both force and displacement are in the same direction. And it will be negative when the object is going up, because force due to gravity is opposite to the displacement of the object. When the object is falling down, gravitational force is doing work to increase the kinetic energy of the object. And when the object is going up, gravitational force does the work to reduce the kinetic energy of the object. How do we determine work done by an external force in lifting or lowering an object? If I have an object on the ground level and I want to lift this object at a certain height h, and we are applying an external force to this. F will be my external force. When I'm applying this external force, I'm doing work against the force due to gravity. Because Fg is acting vertically down, I need to work against the force due to gravity to lift the object. So when we are writing the work kinetic energy theorem, I need to also include the work done by gravitational force. So let Wf be work done by the external force, the force that you are applying to lifting or lowering the object, and Wg will be the work done by gravitational force. When I apply work kinetic energy theorem says that work done is equal to change in kinetic energy. And now my work done will be work done by
External force
plus work done due to gravity equals change in kinetic energy. Now when we are lifting or lowering the object, initially the object is at zero velocity. It is at rest. So velocity will be zero. And when you lift it at a certain height, even at this position, the object is at rest. So again, my velocity becomes zero. So if my initial and final velocities both are zeros, my change in kinetic energy will also be zero. And when you substitute that in the equation here, you get your work done by external force to be negative of the work done due to gravity. So whatever values we determine in the previous part for work done by gravity when the object is falling or going up, work done by the external force in lifting or lowering the object will be opposite to that, negative of that value. So let's take the first case where we are lifting an object. When you are lifting an object, the object is going up. And we determined in the previous part that whenever an object is going up, work done by gravity on that object is negative mgh. And since work done by the external force in lifting the object is negative of work done due to gravity, the work you do to lift an object will be positive mgh. It is opposite to the work done by gravity. Same things apply when you are lowering the object. When you are lowering an object, the object is moving down, it is going down. And we know that whenever the object is going down, work done by gravity on that object is positive mgh. So when you find the work done by the external force in lowering the object, it will be negative of work done due to gravity. That will give me negative mgh. So work done in lifting and lowering the object will be opposite to the work done by gravity. If you can remember the sign for work done by gravity when the object is going up or down, just take the opposite sign for when you are lifting or lowering the object.